Hello, I'm Andy from Race Technology, and in today's little video I just wanted to introduce our new SPEED100 product. So I'm from Race Technology. We specialise in high accuracy GPS, inertial systems, radar, digital video and telemetry systems based here in the UK. Probably what we're best known for is our high accuracy GPS products, which are used in the automotive industry for applications like brake testing, chassis testing, benchmark testing and so on. And that's what the SPEED100 is targeted at. So it's a high accuracy GPS system for general purpose automotive testing. In contrast to our other systems, what's unique about the SPEED100 is its use of a 100 Hz GNSS engine. So I say GNSS as opposed to GPS because it's not just using GPS satellites, it's using GPS, BeiDou, Galileo and GLONAS satellites to give us the best accuracy. And all the parameters, so position and velocities and so on, they're all updated at a true 100 Hz with no interpolation. So each sample is unique. There's no inertial sensors in this. We're really sensing the GNSS data 100 times every second. So that makes it ideal for high bandwidth, high quality GNSS measurements on highway or on the test track. So it's actually based on our existing technology. So as well as the GNSS 100 Hz receiver, which is integrated in here, it's got our standard logging system in there, so we can log data. We can also output data live over CAN or serial. And we also have LTE fully integrated. And the LTE system allows us to get both differential corrections if required into the unit. So rather than its standard 70 centimeters-ish precision, accuracy on position, we can have a 2 centimeter full RTK system running at 100 Hz. So that can come over LTE. Also for LTE, it allows us to log the data internally and automatically upload all the data to the cloud, if that's desirable. In many applications, neither of those needed, so we can just use it as a standalone system, and the data comes out in real time either on CAN or on serial, and that's logged by an external data logging system, or possibly just displayed. So this is the unit, and just to show you around it, so at the front here we have our LCD display that shows system status, any errors, for example SIM card missing. It also tells you whether you're logging, how many satellites are in view and so on. Here we have the USB that allows us to look at live data from the unit if for any sort of diagnosis type applications, or more normally for configuration, so we can configure the CAN output, for example, the frequency of the CAN output and also the addresses that are used. This is the Race Technology standard data port, so that allows it to connect to any of our other systems. So for example, you could use it with an external data logger or an external display. On the back of the unit, we've got a trigger input, which could be used for synchronization with an external data system. We also have a pulse per second, very similar. We could use it for connecting to a third-party data system to synchronize all the data. This is the CAN port, which is the one that would be used in most applications. So that's fully configurable for address, which data is output, and the frequency it's output at. That's all configurable from our PC software. We've also got a data modem input. So in most applications, the NTRIP, the differential corrections, will come over LTE. But for some particular test track applications, there's already a differential station that's installed and transmitting data over a radio connection. So if you prefer to use a radio modem, you can connect it here, and those corrections are routed to the internal GNSS engine. Finally, we've simply got power here, which is on our standard LEMO. We have an LTE connection, and we have the GNSS antenna connection. So that's the main unit. As I say, very flexible. So in some applications, it can be used like as a sensor effectively. So it just outputs data, which is logged by an external system or displayed. In other applications, it can be used completely standalone. So in those cases, you'd normally log the data internally, and then it's uploaded to the Race Technology cloud, so you can download all the test data at a later time. It's also flexible, so we can use it as a standalone system, standalone GNSS, which are with an accuracy of about 70 centimeters, or we can run it in fully differential mode to give you 2 centimeters positional accuracy. In all cases, it's 100 Hz, that's the standard specification. So in terms of applications, they're wide ranging. I would regard it as a general purpose, very high accuracy GPS system. So for benchmarking tests, maybe acceleration tests, test track handling applications and so on highway or off highway. For brake tests, it's probably not the correct unit. I would suggest you look at our Speedbox range of products, and in particular the Speedbox INS is our headline product for very high accuracy brake testing. So you don't have the inertial sensors here. So the big benefit of the Speedbox INS is you also have 3 gyros, 3 accelerometers, so it measures all the inertial states as well for some really high accuracy data with no possibility of dropouts. This is more of a general purpose system. So yeah, hopefully that was a very quick introduction to the system. Say it supplied the box and also the PC software, which hopefully is now being displayed on the screen. The PC software allows you to set up the CAN data output, NMEA serial output, which is nice for some applications. The details, the LTE SIM card, so we need to enter an APN, for example, and a few other straightforward parameters. So it's a fairly straightforward product, so the PC configuration is very, very straightforward as well. Okay, if it's something that's of interest to you, please get in contact with us. Very happy to arrange a demonstration either in the UK or we have international distributors that'd be very pleased to help. Alternatively, we can arrange a team calls and just talk about your application and discuss whether this new product is applicable to yourself.